Today we will discuss about the integration of some trigonometric functions, that is tan x, cot x, secant x, cosecant x. So before we start the integration of the trigonometric functions which I mentioned, first we will write one formula. Integration of 1 by x with respect to x. This is equal to ln x. And because we know that ln is defined only for positive values, this is the reason in this formula we will put modulus or absolute value, and this is an indefinite integral, so we will put plus c, that is the constant of integration. Now suppose we want to find integral of tan x with respect to x. This can be written as integration of sin x over cosine x with respect to x. Now to solve this integral, let us try substitution. Let us put t is equal to cosine x, and now because t is a function of x, therefore we can find dt by dx, and we know that derivative of cos x is equal to negative sin x, and this we can write it as dt is equal to negative sin x dx, or we can write it as negative dt is equal to sin x dx. And therefore the integration becomes integration sin x dx. Sin x dx is equal to negative dt divided by cosine x, and cosine x is equal to t. To observe it in an easy manner, we can write it as the negative sign, we can keep it outside, integration 1 by t dt, and using the formula which we have written just now, this integral will become negative integration 1 by t dt will be equal to ln absolute value of t. And now we will put the original value of t, that is t is equal to cosine x. So this gives us negative ln modulus of cosine x, and this is the formula for integration of tan x with respect to x. This formula which we have received can be written in another form. Using the property of log, we can write it as ln absolute value of cosine x power -1. And this can be written as ln 1 over absolute value of cosine x, and hence we can write it as ln 1 over absolute value of cosine x can be written as absolute value of secant x, because we know that 1 over cosine x is equal to secant x. Proceeding in a similar manner, we can find the integrals of cot x, secant x, cosecant x. So we will write all the four formulas. Integral tan x dx is equal to ln absolute value of secant x plus c, or we can write it as ln absolute value of cos x with a negative sign plus c. The next formula is for integration of cot x with respect to x. This is equal to ln absolute value of sin x plus c, or we can write it as negative ln absolute value of cosecant x plus c. The next formula is for integration of secant x with respect to x, that is equal to ln absolute value of secant x plus tan x plus c. And the last formula is for integration of cosecant x with respect to x. This is equal to negative ln absolute value of cosecant x plus cot x plus c. Now let us solve a question. Evaluate integral ln x over x dx. Let us solve it. So integral ln x over x dx, in a simpler form we can write it as ln x multiplied by 1 by x dx. Now we can use substitution. Let us put t equal to ln x. Now t is a function of x, therefore we can calculate dt by dx, and the derivative of ln x with respect to x will be 1 over x. And this we can write it as dt is equal to 1 by x dx. And therefore, using this substitution in the integral ln x 1 by x dx, we get integral ln x that we have substituted as t 1 by x dx, that is equal to dt. And this becomes t power 2 over 2. And now putting back the original value of t, that is ln x, we get ln x power 2 divided by 2. And at the end, we will add the constant of integration. This is our final answer.